focusing in more closely at a particular type of straight line graph, we're going to be looking at distance time graphs. Now, distance time graphs, distance will always be on the vertical axis, time on the horizontal axis. A distance time graph gives you some idea of the journey taken. On this graph here, we can see that the particle is at rest because it's a flat line component, so it is not moving. So the distance that it's travelled over a period of time hasn't changed. Here and here you can see, and I'll do that in a different colour, here and here you can see that it is moving at a constant speed because it has a constant gradient. It is a straight line graph, just as this side of the graph. It may be looking like it's decreasing, but it's still going at a constant speed. So let's focus in then on our graph here. The distance time graph shows a car's journey from home to school and then to the local shopping centre. What is the total distance travelled? Well, hopefully you can see here that this is the end point of the journey and the total distance travelled was 4 kilometres in that time. So how long is the car resting while at the school? So what part of the graph are we looking at there? So it's the flat part, isn't it? It's that bit there. Now remember, our time is in minutes. Okay, so that flat bit would be 10 minutes because it goes from 10 up to 20. All right, and the last bit there, what is the total distance travelled after 30 minutes? So where is 30 minutes? We're looking at this line here. Okay, and then we read across to there. Okay, and what does that give us? That gives us 3 kilometres when we read off our distance or our vertical axis there. So it really is just a matter of lining up your information like we did in the last exercise. We're asked in this example to sketch a distance time graph displaying all the following information. So let's set up our axes, and of course distance is going to be on the vertical axis, and just reading ahead you can see that the distances are in kilometres, and time will be on the bottom there. And what are our time measured in? It is in hours. So it's really important that we label our axes with our variables and also what units those variables are measured in. Now I'm looking ahead at the information and I've made my scale on my vertical axis. I've gone up in 5s up to 20, and on my horizontal axis I can see that I only really need to go across to 3, so I've gone up in 1s. All right, I'm not interested in any other part of the graph. So let's start. We're told that the total distance covered is 18 kilometres in 3 hours. So I know that I'm going to end up around about here, which is when time is 3 and our distance is 18 kilometres. All right, I've covered 10 kilometres in the first hour. So in the first hour, I am at that spot there. Then I'm told that I have a 1 hour long rest after the first hour. So that would be between the first hour and the second hour. I don't travel anywhere. And then obviously I've got to finish my journey off to get up to that total distance of 18 kilometres in 3 hours. So that is what my graph looks like. Again, that bit there is 3 and that bit there is my 18. So that is my graph.